Hello dear colleagues engineers, in this video I am going to analyze the dynamics method on specific existing examples using reverse engineering technique. So let's have a look at a modern car and a first car, which was then called the self-running carriage. At the initial state of development, the car moved slowly, and then there was no risk of losing traction on the road surface. The self-running carriage didn't have any shock absorbers, and the need for them wasn't evident at the beginning of development. With an increase of possible speed of movement, they found the following negative factor. Unevennesses on the road causes oscillation, vertical movements, which entail weak grip, loss of controllability, and decreased braking efficiency, and even not comfortable in such a self-running carriage, as continuously shaking and throwing up. There are apparent negative environmental factors that have an impact on a technical system, a car. There was a task to eliminate or reduce the negative impact to a minimal level. How did they come up with it? Imagine you still do not know about the construction of the shock absorber. Then the first thing that comes to mind is the next decision, to make the roads for cars perfectly smooth. However, there is another problem that arises. It is impossible to make all roads ideal for cars in a short period. It can take many years. This path leads us in the wrong direction, to the changes in the external environment. Our task is to develop the newly created technical system, a car. Let's see what kind of impact a road has on a car in the process of driving a car on it. When there is a pit on the road, a wheel of a car moves in a vertical plane to the bottom of a pit. When there is a bump on the road, a wheel moves vertically upwards, throwing up a car. To find an idea to solve the task, for the first let's imagine the following perfect final result. The wheel is in contact with the road and shouldn't come off the road surface, regardless of the occurrence of bumps or concavities of the road surface. And at the same time, the car body shouldn't toss up or swing down. The key word here is regardless, or in another word, independent. The wheel should be independent of the car body. So how to make it independent from the body, but dependent on the road? There are several numbers of techniques for resolving technical contradictions that have been applied to the solution of this problem. But for educational purposes, I show you only how the dynamics method can help you. The following recommendations prescribe for us. The characteristics of the object or environment must change to be optimal at each stage of work. Split the object into parts that can move relatively to each other. If the object in the chain is stationary, make it movable. When solving this task, the body was made stationary and the wheel was additionally made movable in a vertical plane for damping vibrations from road irregularities. This example of applying the dynamics method has been shown to attract your attention to those actions and their sequences which you specify in the process of working on tasks in production. So first you should set a perfect final result, and then choose the method that can lead you precisely the way to an area with new ideas to solve a task or an issue or a problem. That's all for technique dynamics. Have a practice this technique over the next day, and it will become your reliable tool in unsolvable situations. And also remember, there are no unsolvable situations. I know you can find a solution.